Hi, this is Dr. Eddie Morgan over at Clovis East High School. I want to help you with your homework tonight. We have a homework help sheet for worksheet 9.4 in Math 1. Remember, every problem in this homework help mirrors the problem on your homework. So if you're having a problem with one or two specific problems, just fast forward to those problems and we should be able to help you out. So let's get started. Problem 1 asks us to figure out whether this triangle is scalene, isosceles, or quadrilateral, equilateral. Now notice what I've already done to the problem. Like for xy, notice how I've already drawn a right triangle here and here, because I noted that to find this, the formula is, the distance is x squared plus y squared, square root of the whole thing. But I know it simply as 2 squared plus 5 squared equals the distance squared. And so I can look at this and know, okay, 2 squared plus 5 squared equals that squared, or it's the square root of it. So this one's going to be 2 squared plus 5 squared. So that's going to be 4 plus 25, or the square root of 29. And for now, we'll just leave it there. What we're trying to figure out is, are any of these sides equal to each other? So now when I move to the next one, when I move to YZ, here's my triangle that says that 2 squared plus 5 squared equals that. Well, immediately, without even doing the calculation, I should go, wait a second, 2 and 5? Wasn't that the last one? Yeah. So you see here, when I do the math, I end up with the same thing. So now I know I have two sides that are equal. So this side equals this side. So at this point, we have a isosceles triangle and an isosceles triangle. Let's see what the last one is. We look at the last side, however, and its triangle is 3 and 7. So that's going to be 3 squared plus 7 squared. And I know that's not going to be the same as the other two. That's going to be 9 and 49, or the square root of 58. So it means I have two sides that are the same. So a triangle that has two congruent sides is an isosceles triangle. All right, number 2 wants to know whether these are scalene, isosceles, or equilateral triangles again. Once again, I've already shown you the triangles that I normally draw when I'm doing this. When I start with xy, I look at this triangle here. See, it's a right triangle. So I know that 4 squared plus y squared equals xy squared. Or if I squared them both, xy equals the square root of 5 squared plus 4 squared. So that's 25 plus 16, or the square root of 41. And we'll leave it alone there. My next one, notice my triangle here is 1 and 6. So that's going to be 1 squared plus 6 squared. So 1 and 36, or the square root of 37. So those are not equal. And then my last triangle, ZX here, is the sides of that right triangle are 2 and 4. So I end up here with 4 squared plus 2 squared, which is 16 plus 4, or the square root of 20. Now looking at those, I notice that none of them are the same. And when you have a triangle where all three sides are different, you have yourself a square root triangle. Okay. By the way, just noting, if you were ever to simplify this one, you could write that this is the square root of 4 times 5, or 2 times 2. I have a 2 times 2, or 2 squared, so that comes out and becomes just a regular 2 to here. The 5 stays the same, and that could be simplified to 2 radical 5. Problem 3 is very much like problem 2. We're trying to find out if the triangle is scalene, isosceles, or equilateral. Let's start with xy. Notice again, I've already drawn my triangles that you could draw too, and it's 4 by 7. So xy squared is 4 squared plus 7 squared, or I could say that xy is the square root of 4 squared plus 7 squared. So that's 16 plus 49, or the square root of 65. Now we move on to yz, and notice that triangle there is 2 and 8. So yz is the square root of 2 squared plus 8 squared, or 8 squared plus 2 squared. So that's 64 plus 4, or the square root of 68. And then finally, our last side is 4 and 5. So that's going to be the square root of 5 squared plus 4 squared. So that's going to be 25 plus 16, or the square root of 41. Now you'll notice again, all three of them are different, so this triangle, like number 2, is a scalene triangle. Once again, you see we could simplify this if we wanted to reduce down to get the simplest radical. That's not always necessary. It will be next year in Math 2, so something good to see. Again, we're trying to find whether the triangle is scalene, isosceles, or equilateral. Let's start with xy. We notice it's 3 and 9. So xy, or xy squared, is 3 squared and 9 squared. So xy is the square root of 3 squared plus 9 squared. And that's going to be 9 plus 81. So that's the square root of 90. You could break that out, by the way, and notice that there is a 3 squared in there. So that could come out and become your 3. And then but you're left with a 2 and a 5. So that simplifies to 3 radical 10. Now when we go to the next one, you notice there's no triangle because it's simply a horizontal line here. So I could just count it. 1, 2, 3, 4, 5, 6 spaces. So it's simply going to be 6. And then my final triangle, ZX, is 9 and 3. Once again, I should notice, by the way, 9 and 3 is just like the other one. So I've got another one that's going to be 9 squared plus 3 squared, square root of 90, or 3 radical 10. At this point, we look and notice that we have two sides that are 3 radical 10. So we have ourselves an isosceles triangle. In problem 5, we're moving into quadrilaterals. The key thing to notice in quadrilaterals, if you find out that the opposite sides, both opposite sides are congruent, or equal, you have yourself a parallelogram. You could also find that out by finding that the slopes of the opposite sides are the same. That's a parallelogram too. Then at that point you have to look for things like, are all 4 sides the same? Then you'd have a rhombus. And then next you'd have to look, if you're looking into a square or rectangle, you'd have to say, are any of the sides perpendicular right angles? So let's get started with the first one. Let's look at AB first, and just like we did with the triangles, make the square, the triangle. So notice this triangle is 4 by 4. So AB squared is 4 squared plus 4 squared. So AB is the square root of 4 squared plus 4 squared. Square root of 16, or the square root of 32. And that breaks down to simply 4 radical 2. We go to the next one, BC. It's not the same length. It's 4 and 2. So it's going to be 4 squared plus 2 squared, or 16 plus 4. That's going to be my square root of 20. Or it can be reduced down to 2 radical 5. We come around to CD now. Notice we have 4, 4 again. So we know that's going to be the same as AB, because the triangle is the same. So that's going to be 4 radical 2. And then finally, DA is the same, notice 4 and 2, as BC was. So in this case here, we now have a quadrilateral with opposite sides that are equal. So we can conclude that that's a parallelogram. We look at the angles and we realize those are not right angles. So we're safe in saying it's a parallelogram. If they were close, then we would have to compare the slopes to see if we had perpendicular lines. Problem 6, again we have a quadrilateral. You look at it and you can almost tell what it is, but in this problem we have to prove it. It looks like a square. But to be a square, all the sides would have to be the same, and the angles would have to be right angles. They would have to be perpendicular. The lines would have to be perpendicular. So let's get started finding the sides. First line for AB, we notice it's 3 and 3. So AB is the square root of 3 squared plus 3 squared. That's going to be 9 plus 9, the square root of 18, or 3 radical 2. When we go to BC, we notice, oh, that's 3 and 3 as well. So that's going to be the same thing, square root of 3 squared plus 3 squared. And when we go to CD, 3 and 3. So those are 3 sides that are the same. And finally, the last one, 3 and 3. So 3 squared plus 3 squared, 18, and we end the square root. So at this point, we know that we not only have a parallelogram, because opposite sides are equal. I mean, this side equals this side, and this side equals that. That would be a parallelogram. But since they're all 4 equal, we have a rhombus. Now the only question is, are the angles perpendicular? So to be perpendicular, like if I have the slope of one line is A over B, the slope of a perpendicular line is the opposite reciprocal. Okay? So in this case, the slope of AB, you'll notice here, is from A to B, it drops down 3 and over 3, so it's negative 3 over 3, which is negative 1. Now the slope of CB, the one next to it, from here to here, it goes up 3 and over 3, so it's simply 3 over 3, which is positive 1. And if you think about this for a minute, if this slope is positive 1, and I write it like this, positive 1 over 1, the perpendicular would be the opposite, and flip them over 1 over 1, which is negative 1. So these two are perpendicular lines. So that means that this is a right angle right here. And you can see that you do that with all 4 of them, and you have 4 right angles. So you can conclude at that point, having done that, that this is a square. All 4 sides are the same, and you have 4 right angles. So we look at number 7. It obviously looks like a kite. But to prove it's a kite, we have to show that there are 2 pairs of consecutive sides that are equal. So let's figure out the sides again. Notice for our first triangle here, PQ, the sides are 3 and 2. So it's 3 squared plus 2 squared square root. That's going to be 9 plus 4, or the square root of 13. For QR, our triangle that we draw here is 5 and 3. So that's going to be 5 squared plus 3 squared, or 25 plus 9, or the square root of 34. Now when we come to the next one, RS, we notice it's also 3, 5. So it will be the same size, 34. So we now have this side equal to this side. That's halfway there. And as we come to our final one, notice it is 2 and 3, just like PQ. So in this case here, 2 squared plus 3 squared is 13. And now we've proven that this side equals this side. So 2 consecutive sides are congruent, 2 consecutive sides are congruent. So therefore, this is indeed a kite. So we look at our drawing. Number 8 looks like a rectangle. To prove that, however, we need to prove that the opposite sides are equal and that they are the 2 lines are perpendicular, have opposite reciprocals, meaning they're right angles. So let's get started with the sides. Our first one, EF, notice our triangle is 3, 3, so it's 3 squared plus 3 squared. It's going to be 9 plus 9 to the square root of 18, which is 3 radical 2. FG is 5 and 5, so that's going to be 5 squared plus 5 squared, 25 to the square root of 50, which reduces down to 5 radical 2. And then we get to GH, and we notice it's 3 and 3, just like EF. So that's going to equal that. So now I know this side equals that side, halfway there. And as we go to our last one, we have 5 and 5, just like FG. So that side is going to be equal as well. So now we've proved this side equals that side, and this side equals that side. And we've proved that this is a parallelogram. Now we just got to see whether it's a perpendicular. What would make this a right angle? Again, the slopes would be opposite reciprocals. So if I look at the slope of EF, notice it goes down 3 and over 3. So it's minus 3 over 3, or minus 1. When I go look at the slope of FG, start here, it goes up 5 and over 5. So it's 5 over 5, which is 1. And just like the problem before, notice that these are opposite reciprocals. So these two are perpendicular. When I go to look at GH, here again, from here it goes down 3 and over 3. So that's minus 1. So these two are perpendicular. And then if I look at the slope of HE, that is up 5 and over 5. So that's 5 over 5, or 1. So these two are perpendicular. And of course, I could run this one back to here as perpendicular. So what I've proven here is that all of these 4 angles are right angles. So that means this is indeed a rectangle. And by the way, just as a note, we proved it was a parallelogram because the opposite sides are equal. But notice that the opposite sides are also parallel. See, this side and this side are the same. They're parallel. And likewise, this side and this side are the same. So that's another way of proving that they are parallel. All right, number 9 tells us to determine the most precise name for the quadrilateral with the vertices -2, 2, 2, 5, 2, 0, -2, 3. Now, I've already drawn these in here. So obviously, if you're working on yours, you're going to have to start at the origin right here. And like -2 would be -2, and then up 2 would be A. So that's -2 and up 2 is A. And do that for each of these. Now we look at it, it looks like a parallelogram, but the one thing we have to consider is it could be a rhombus because the sides look like they might be the same. Let's start by proving it's a parallelogram, and let's do it different this time. Let's just look at the slopes. So if we look at the slopes here, for example, I can see that AD, for example, is rise over run. Remember, slope is rise over run. That's the change in y, the up and down, over the change in x, which is horizontal. So in this case, in AD, it goes up 5, but it doesn't go over at all. And likewise, same with BC. The y goes up 5, but x is 0. Now, you can't divide by 0, and so that's why this is undefined. Now, just remember this, because this shows up on the test, and a lot of students will tell me that equals 0. No, it's 5 divided by 0, and it's undefined. But because they are the same, it means that these two sides are parallel, okay? So that means AD and BC are parallel. Likewise, if you notice here, AB is up 3 and over 4, so that's 3 over 4. And this one, likewise, is up 3 and over 4, as you can see on the other side. So as a result, these two lines are also parallel. So this is parallel. I'll put a double arrow. And this is 2 parallel. And another way to define a parallelogram, if opposite sides are parallel, 2 sets of parallel lines, this is a parallelogram. So we know now that this is a parallelogram. Now, to determine if it might be a rhombus, we have to just figure out what the sides are. So notice that AD and AB are easy because we can just count them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So these two sides are equal. And we got to figure out what the other one is. Notice when I draw my triangle here, though, what kind of triangle do I have? You should see I have 3, 4. You should, without any calculation, say, oh, this is a 3, 4, 5 triangle. But if you forget, you can say, okay, it's 3 squared plus 4 squared equals that. So 3 squared and 4 squared is 9 plus 16 is 25. That equals 5. And when we move down to CD, notice we have 3 and 4 again. And so that equals 5. And as a result, we now see that all 4 sides are the same length. So if I have a parallelogram and they're all equal, then I've got myself a rhombus. All right. So this one, they want us to prove that it's a rectangle by using the distance and slope formulas. This is identical to a problem on the test. You just got to find the slopes and there. So first thing I notice is that, and I'm going to do a little different approach. I notice that HE is 5 squared and 5 squared. And I also know that FG is 5 squared and 5 squared. So whatever that is, they're the same. So they're both going to be 5 squared plus 5 squared, or 25 and 25 are square root of 50. So those two are the same. So this side equals this side. And then the same can be said for the other two sides. Notice here is 3 and 3 and 3 and 3. So whatever they are, it's going to be the same. And the length is going to be the square root of 3 squared plus 3 squared, or 9 plus 9 is 18. And so at this point, we've shown that opposite sides are equal. So this is a parallelogram. To be a rectangle, though, we need to look at the slopes. So let's start off here first with, notice that HE is up 5 and over 5. 5 over 5, or 1. Likewise, this one is up 5 and over 5. 5 over 5. So as we expected, they're parallel, and the slope is equal to 1. On the other hand, the other two sides, notice this one goes down 3 and over 3. So it's negative 1. And likewise, this is down 3 and over 3, negative 1. And as we said in an earlier problem, that means these two are opposite reciprocals. And if you don't remember how, remember that if the slope of a line is AB, A over B, then the parallel is the opposite, positive, negative, B over A. Now here I have a slope that is 1. Let me write that as a fraction. So the opposite would be negative 1 over 1, or negative 1. So notice these are opposite reciprocals, or perpendicular. So that means that each of these angles is a perpendicular. And so we have now proved that this is indeed a rectangle. Problem 11 asks us to describe how you can show whether a quadrilateral in a coordinate plane is a kite. Well, what's the definition of a kite? A kite, in a kite, you have 4 sides, and you have 2 pairs of consecutive sides, meaning they're next to each other, that are congruent. All right? So what you have to do then is find the measure of each side. And if you have 2 pairs next to each other, if you have 2 sides that next to each other that are equal and another 2 sides that are equal to each other, you have yourself a kite. By the way, if all 4 sides are the same, then you would have a rhombus.